Kindly come forward for the first technical presentation for the day. Ladies and gentlemen, please put your hands together for Mr. Bob Follner.
Thank you for the kind introduction. I'm excited to be here at the BBB in India. So I represent Air Products. We're a Fortune 500 company based out of the United States. We have over $12 billion in annual revenue and have been in business for over 80 years. Our core business at Air Products is owning and operating industrial gas production facilities. We operate over 750 of these, with many of them being cryogenic air separation, but also hydrogen production facilities and green hydrogen production facilities, like a massive project in NEOM. My specific business unit at Air Products is Membrane Solutions. We provide membranes to help biogas producers upgrade biogas, raw biogas, to biomethane. At Air Products, safety is our #1 priority. The only acceptable goal is 0 accidents or incidents. As I said, I represent Membrane Solutions. We're a sale of equipment business within larger Air Products. And we operate 4 different business segments. The first business segment is our OEM business, or our membrane separator business, where we partner with system integrators, many of whom are in the room today, to provide membrane separators to do the biogas upgrading. We also operate an ETO business, an engineer-to-order business, in industries like SAF and biodiesel to help recover hydrogen from their systems. And we also have a marine business, which is a nitrogen generation business, and we support all of that with a global support and service business. Our membrane business is headquartered in St. Louis in the United States. With our corporate headquarter being in Allentown, we have a systems business in Norway and an office in China. Our India business is centered out of Pune, and we have some local representation here as well. I want to talk a little bit about membrane technology. So a membrane separator, and I have an example here, is basically a pressure vessel filled with thousands of hollow polymer fibers. These fibers are all about the size of a human hair, and gas comes through this membrane port and through the bore, travels through the fiber, and then you have fast gases and slow gases in a compressed gas stream. The slow gas stream goes all the way through the pressure vessel and enters out of the bottom of the separator. And then you have the fast gases will permeate out from the pressure vessel and out through the permeate ports. In biogas, the slow gas is your methane, which will remain at pressure, and your fast gas is CO2, which will permeate out at lower pressure. All of this is governed by permeability and solution diffusion properties. So permeability is a function of both diffusivity and solubility of the gases. The diffusion is basically the size of the molecule. Is it a big molecule or is it a small molecule? And the solubility is how that molecule interacts with the membrane. Down on the bottom of the screen, you have a spectrum of various gases and their permeability. The farther apart the gases are on this spectrum, the easier it is to separate those. So the 2 circled ones, methane and CO2, are the primary separation in this biogas market, where you're trying to purify and recover methane from a mixed gas stream of membrane and CO2. So membrane technology in practice is very proven in the field. This is a schematic of a typical biogas facility. You would have a feedstock. In India, these feedstocks tend to be sugarcane, Napier grass, or municipal waste. And the feedstocks will really determine what that raw biogas stream looks like. Is it going to be CO2 heavy? Is it going to be methane heavy? What are the impurity profiles? Upgrade the biogas to biomethane in order to ultimately be able to compress that and put it into the compressed biogas system. The pretreatment is of the utmost importance in conditioning the gas. The membranes cannot do their job unless the membranes or the gas is adequately conditioned ahead of that. So Air Products offers a number of different options for upgrading biogas to biomethane. Ultimately, there's 3 different types of designs, 2, 3, and 4-stage systems. 2-stage systems are ubiquitous here in India, and in other regions, 3 and 4-stage systems are more popular. I'll start with the highest recovery 4-stage systems and work back to the 2-stage system that is popular here in India. So this offers, the choice of system is really dependent on what type of performance you need to get out of it. And there's a number of trade-offs when you're looking at that. So they're trading off power consumption, OpEx and CapEx based on the size of the system. So a 4-stage system is going to be one of your highest recovery options. That's largely used in Europe and places where there's very low methane slip requirement. It's also a very high capital investment. And then 3-stage is the most commonly used. It's a little bit of a lower methane slip, also very commonly used in Europe and throughout the world. And then here in India, we have a 2-stage system. And we'll go into details of these a little bit further. So this is a 4-stage system, and this chart behind me looks at a number of different options and compares it to the industry standard 3-stage system. So you have 2 different rows on this chart. The first row on the chart is the relative membrane quantity. So that is set to 100% in each of these scenarios, and then the second is power consumption. So Air Products has designed a number of different cycles within a 4-stage design to really drive recovery and methane purity. All of these scenarios are looking at 99.8% recovery, so very low methane slip of 0.2%, and very high purity of 98.75%. As you kind of go across the row, you'll see that the membrane quantity changes with condition changes, with 109% in a 14-bar compression scenario, a 100%, so the same type of membrane count in the 16-bar scenario, and then a higher 116% membrane count in a 2-compressor cycle. But the 2-compressor cycle has a lot of operational benefits, and it could actually bring down your operating costs and has a lower power consumption than some of the other options, including the more standard 3-stage system. So for operators that are really concerned about operating costs, looking at some unique designs like a 2-compressor design can offer some long-term operating benefits. On the 3-stage side, similar scenario. So most 3-stage, when people think 3-stage design, they think of a standard 3-stage system, which is the baseline in green, but there's other options as well. For instance, if you put an interstage pump or interstage blower, you can really reduce your membrane quantity by almost 30% and also reduce your operating costs marginally. And by operating a 3-stage design with a vacuum, you can also reduce your membrane quantity and reduce your operating costs. So it's not a one-size-fits-all scenario for 4-stage or 3-stage systems. There's a lot of options at your disposal. Now, these are not really used widely in India right now. As the industry continues to evolve, you may see a move into 3- and 4-stage systems, as we have in other parts of the world. In India, 2-stage systems are by far the most frequent. The first stage of the system really drives recovery. The goal of the first stage is to recover as much of your methane as possible, and then the second stage really drives your purity. So it's important that the 2 stages operate in tandem. At Air Products, we use 2 different types of polymer to accomplish this, with the first stage polymer really being optimized for recovery, and the second stage polymer being optimized for purity. So this chart looks at 2-stage systems, and all these are different design comparisons. Starting on the left of the slide, you have a 97% recovery, 99% purity scenario, and then the various other scenarios as well, just to give you an idea of how membrane and power changes with changes in parameters. So the 97% recovery 98% purity scenario will have less membrane usage than the previous scenario, with slightly lower power consumption. If you step up a level to 98% recovery and 99% purity, you'll have higher membrane content and slightly higher power as well. And then in a 98% scenario, a slightly lower percentage of membranes and a slight uptick in power consumption. So we can really design and optimize these depending on what the parameters you are. Usually in India, we're seeing at least 95% purity, moving up to 97% purity. And then there's been an increase in desire for higher recovery systems in recent times. So we have a number of operating references here in India. One of the references is shown here. This is a sugary waste feedstock. It was a 12-ton per day facility, and it's currently operating today with no issues. It's been operational since March of 2025. So kind of wrapping things up, some of the key differentiators for Air Products membrane solutions in the market. First and foremost, we really view ourselves as design partners for our OEM partners and for the industry at large. We really pride ourselves on being a partner and helping look at these unique situations and design novel biogas cycles for upgrading, so to really tailor the solution for our customers and drive both OpEx and CapEx savings. In addition, we have a really strong application engineering support, as well as some local support here. So we have a team of engineers that can really help do simulation support and optimize those systems. So kind of to wrap things up here, Air Products is dedicated to the market here in India and really excited to partner with folks in this room and elsewhere to help drive the biogas and biomethane market here in India. So thank you for having me.
Thank you so much, Mr. Foreigner. Ladies and gentlemen, that was Mr. Bob Foreigner from Air Products for the technical presentation on 2, 3, and 4-stage biogas upgradation systems. And now it's time for the second technical presentation. I request Mr. Ashwin KP from Tetra Pump to kindly come forward and give away the technical presentation on heat pumps for CBG and MSW plants. Ladies and gentlemen, please put your hands together for Mr. Ashwin KP.
Hi everyone. I'll spend the next 10 minutes explaining a relatively new technology in the space, heat pumps for CBG and MSW plants. You might be wondering why I'm talking about heating in a CBG conference. And the key question that I'm driving is to understand how much does a typical CBG plant spend on heating. The number is that around 8% of the raw biogas that is generated by a typical digester is redirected back into your hot water generator for generating heat to maintain these digesters. So that's a significant amount. For a 12 TPD plant, you are spending around 40 lakhs to 2 crore rupees worth of gas that you could have been selling in the market just for heating. But why do you really want to heat these digesters? This graph basically shows how much gas is generated at various temperatures. The orange graph shows a typical mesophilic operation, which says that you get your maximum production at around 38 degrees. The thermophilic, the blue graph shows that says that you will get your maximum production at around 52 degrees. What I want to drive at more here is that every 5-degree reduction in the temperature of your digester leads to a 25% yield loss. Hence, it's very important that we maintain our digesters at the required temperatures, because you are actually losing a lot of money by not maintaining these tank temperatures. And this is the reason why we are burning gas or anything else to heat it. But having said that, not all heat is at the same cost. This shows that what is the cost to generate heat using different fuels. If you are using electricity to generate heat, you will be spending 9 rupees of electricity to generate 1000 kilocalories. If you are burning raw biogas, you're spending around 7 rupees. If you're using briquettes or biomass, you'll be spending around 3 rupees. Heat pumps are one of the cheapest cost methodologies, technologies to generate heat for CBG plants. And while briquettes and paddy being burnt in boilers is cheap, there are many other costs associated with it. Biomass is cheap for generating heat, but you need to account for storage. A large piece of storage is needed for storing biomass. During monsoon, 10 to 15% water gets added to the biomass, so a lot of energy gets spent in removing the water from the biomass. A lot of labor is involved in handling and storage of these systems, and also supply is not very constant. So while biomass is relatively cheap, there are a lot of additional costs associated with it, which heat pump as a new technology helps you solve. And also, why do we not need boilers in a CBG plant? If you look at the thermal profile of an entire CBG plant, you will realize that every application is less than 100 degrees, whether it be a foam drying or pasteurization or digester heating, which is the constant load throughout the entire biomass plant, CBG plant, which is the largest continuous load, or whether it be substrate preheating. All these applications are less than 70, 80 degrees Celsius, which can all be taken care, which is a sweet spot for heat pumps to operate, which can generate heat at much lower cost, much lower carbon footprint, and much lower maintenance as well. While we need heat for these digester heating, we are already generating a lot of waste heat inside these plants. If you look at a typical CBG plant, in your upgradation facility, your compressors are rejecting all the heat which you are putting into the atmosphere or the cooling towers. If you are running a power plant based on CBG, your jacket water is rejecting a lot of heat. Your effluents, your slurry is just rejecting heat into the environment. So on one place, you are burning energy and rejecting into the environment, and on the other place, to maintain heat, you are again burning fossil fuels, raw biogas or briquettes. A heat pump's job is to take the heat from where you are wasting at low temperature at 30 degrees, upgrade it to 90 degrees, and then give it to your digester. And so you are reusing the heat within your entire CBG plant and making it much more efficient. And that's the biggest driving factor. There is a 4:1 efficiency difference between a boiler and a heat pump. A boiler typically converts 80% of its input energy into heat. Heat pump can convert 1 unit of electricity put in to around 3 units of heating. So from 80% efficiency to 300% efficiency, there is a 4:1 efficiency improvement when you move away from a hot water generator or a boiler to a heat pump, which not only drives economics, but also drives your carbon footprint down, your maintenance down, and many other benefits. The heat pump that we provide has a brand name of Tetra Heat. It is using one compressor and provides two products. It provides cooling on one side and heating on the other side. It has a COP, or the efficiency, of 3 to 6, 70% reduction in primary energy, and it can simultaneously generate hot water up to 120 degrees and chilled water up to 7 degrees. In a CBG plant, I can generate hot water up to 55 degrees for mesophilic or 80 degrees for a thermophilic process, as well as generate cooling for your compressor cooling, intercoolers, your membrane cooling, your LP coolers, your CO2 liquefaction plants, etc. And while it might be relatively new in this sector, it's fairly well established and standard across many other industries. We have references of our own units which have been running for 60 months, non-stop, 24/7, with effective COPs or efficiencies of 4.11, 55% reduction in your gas consumption. There have been recent plants which have been saving 1.5 crores per year of savings with a 20-year lifespan and 600 tons of CO2 reduction. This is one of the case studies of a recent project that we have. But not just this one, we have had multiple case studies across multiple sectors. This is a 250 kilowatt plant generating 75-degree hot water, 800 kilowatt facility which is generating 88 degrees Celsius, relevant for a thermophilic process, 700 kilowatt at 90 degrees Celsius, 100 kilowatt for a 60 degree, which is kind of the application needed for a mesophilic plant, 300 kilowatt. This has been running for almost 4 years continuously with no downtime. 600 kilowatt at 90 degrees across multiple sectors, CBG, FMCG, auto, textile, pharma, and other sectors as well. Within a CBG plant, which is the focus of this exhibition, where can we put a potential heat pump? We can put it for substrate preheating, pasteurization, foam dryers. We can use it, the cooling side of the heat pump for cooling your compressors, intercoolers, etc. But the main application where there's a continuous load is for your digester heating, where we can always maintain your digesters at 38 degrees for mesophilic and 52 for thermophilic across the year, continuously for multiples of years, eliminating the need for your fossil fuels. And the final thing is that decarbonization is now mandated. Using raw biogas again in your hot water generator will count against your CCTS or your carbon credit scheme. By using heat pumps, we can move away from scope 1 emissions to scope 2 emissions. And scope 2 emissions, we can completely decarbonize by using renewable electricity. And hence, you can become a zero carbon CBG producing entity. That can actually lead to an additional uptick in your IRRs by 10 to 15%, if not more. So apart from the lower running cost, lower carbon footprint, you are also going to be improving your IRRs on your plant as well. That's what I wanted to share with you. Just a quick one line about us. We are Tetra Heat. It's a Promethean energy brand based in Mumbai, founded by IIT Bombay founders. We have 50 engineers. We have 150 plus industrial deployments, and we serve across multiple verticals. We are trusted by among the top 50 companies in the Indian Sensex. Almost half of us have worked with us. Having said that, I know it's a relatively new technology. I would recommend that you just stop by our booth, which is stand A31. We have a heat pump which is kept in our stand. Our team would be happy to take you through the internals of a heat pump, how it works, what are the benefits, does it work for your plant or not, and how we can work together. So we are happy to do a plant walkthrough and take you through the technology. Thank you, everyone.
Thank you so much, sir, for the technical presentation on heat pumps for CBG and MSW plants. It's now time for the last technical presentation for the day by Protego. I request Mr. Matt Cooper to kindly come forward and deliver a technical presentation on pressure vacuum relief valve. Ladies and gentlemen, please put your hands together for Mr. Matt Cooper.
Thank you for the introduction, and also thank you to the committee for inviting us along to do this presentation. What I'm going to just introduce to you now is a relatively simple technology that often gets overlooked, but it can have a significant impact both from a safety perspective, but also from an operational efficiency perspective, and therefore from not only a money perspective, but also an environmental concern perspective. So just a very brief introduction to the company. Protego is over 70 years old. We are a German research and development company situated in Braunschweig. In India, we have been operating a facility, a manufacturing facility here since 1990. And the company started originally with the patent over 100 years ago of the very first detonation flame arrestor. So we work in a relatively small niche, and as such we do a lot of research and development because there are not many companies that are able to do what we do. Just very briefly, this is some of the technology we have at our facility in Germany. So we have the largest flow test facility of its kind in the world. This is very critical when you're looking at large storage facilities. Typically, these are related to storage tanks, but it's also very critical for the biogas industry with the significant volumes of gas that you are producing and then storing. So very quickly, looking at emissions control, if you have a storage tank or if you have a gas balloon or some kind of storage of your biogas, you are potentially going to have two scenarios, an overpressure scenario or an underpressure scenario. So in its most basic form, with the overpressure scenario, the valve will open at the predetermined set point and relieve that set pressure in much a similar way that a pressure safety valve would. And you can get that from changes in temperature, you can get that from filling or discharging from the tank or the storage balloon. And on the exact opposite side, you can also have the opposite effect in a vacuum condition, whether that be because you're withdrawing product or because you've had temperature changes, or perhaps you've had an atmospheric change due to the weather, the current weather. So just a very quick video to show you this in principle. So here we have the insides of a pressure vacuum relief valve. So as the pressure increases within the tank on the left-hand side there, eventually the force is sufficient to lift that pallet and it will allow the pressure to escape. Conversely, when the pressure inside starts to reduce, you have enough external force to open up that valve and it will allow the air to breathe in. So this is how we stop the vessel or whatever you are storing your gases in from exploding or imploding. And this is just a live video to show you in principle what that looks like. Okay, so there we hit our set point, the valve will open and it will allow those vapors to escape. If we put more weight on those pallets, then obviously the set pressure will increase because you then need more force to overcome gravity and release that, the vapors. This is just looking at the different kind of technology. So within the breather valve world that we're using to protect these facilities, the most common technology is something called 100% or modulating technology. At Protego, and we pioneered this probably 30, 40 years ago, we actually go away from the 100% to the full lift 10% technology, because as you can see on the screen there, for every given opening cycle, you relieve less vapors to the atmosphere. And what that means is during that opening cycle, you're losing less of your product, so you can keep more of it to sell, and fundamentally you are actually emitting less to the atmosphere. So from a emissions perspective, you're also significantly reducing your emissions to atmosphere. But in this world, because we're talking about very low pressures, we're not in an API 527 or a high pressure safety valve scenario. So what we're looking at here, and the overlaying standard for this, is something called API 2000. API 2000 is for these breather valves that operate on storage facilities at 1 bar or less. And because they're operating at such low pressures, which the differential between the set pressure and the setting is really low, API 2000 allows for some form of leakage. Okay? In a high pressure safety valve world, you don't have leakage because you don't operate near the set point. But what you can see here is the difference between a poor quality valve and a high quality Protego valve. Both of those were operating at the same pressure, they had the same setting, but as you could see from the start, the first valve was constantly leaking. So this is an extract from that standard, and this should be considered the minimum requirement for the CBG world. This is what dictates that you have a higher quality valve. And as you can see there, depending on the size of the valve, at 75% of the set pressure, you are allowed a certain volume of leakage. Okay. So if we look through the opening and the characteristics of the valve, as the pressure inside your storage facility increases, the valve should remain closed. And this is the vast majority of the time. Eventually you hit your set pressure, at which point you expect your valve to open, and then it will allow that pressure to dissipate until such a time as the pressure then drops. But what we have to consider is below that set pressure, you have this leakage area. Now, Protego, as I mentioned, we operate a higher quality valve. So whilst API 2000 stipulates the leakage area at 75% of the set pressure. Protego measures it at 90. Not only that, if we compare the volume of leakage that's allowed, so API 2000, you can see there at 75% allows quite a high volume of leakage. When Protego measures their valves, and every single valve has to go on a test bench before it leaves the factory, the leakage rates are done at 90%, and the volume, you can see we have a reduction in leakage of anywhere from 84 to 99%. If we then take this a little bit further and we think about particularly biogas plants or compressed biogas situations, because they're being stored at very, very low settings, the operating pressure of those facilities is often far in excess of that 75% set point. So if you stipulate as a minimum API 2000, that's a good step in the right direction. But what you will find is that quite frequently, even if you have a valve that passes API 2000, because you're operating at maybe 80 to 90%, you will still have significant leakage from those valves. And that leakage, as we said, is your product that you've developed, you've actually made, and also you're then emitting to atmosphere. So we saw this video, and whilst this could be perhaps a poor quality breather valve, what we could also be seeing here is an API 2000 compliant valve, the one on the left, but we're just operating at a higher relative set point, so we're within that 75% window. Okay. This is just an example looking at some of the cost savings. So we do a lot of calculations for our customers. Typically, because we're in storage tanks, we do a lot of calculations based on nitrogen, but the principle is exactly the same, and we can do that based on the value, your own values for the methane that you are producing. And obviously this will be part of the slide pack, so you can review these numbers later and we can talk to you about amending these numbers. But what is critical to understand is that, and the reason that Protego goes way beyond API 2000, the API 2000 standard was developed from the API 2521. And those leakage rates that were developed for API 2521 were developed in 1966. And in 1966, we didn't have huge concerns about the cost of nitrogen or perhaps the cost of methane, or perhaps more importantly, the impact of emissions to atmosphere for something like methane, which is obviously one of the most severe greenhouse gases. So you can see that these 1966 values are perhaps not where we need to be. As a bare minimum, it is the recognized international standard, so you should be compliant with API 2000 as a minimum, but we would always suggest that you try and take it beyond that to make sure that you have the most efficient facility. And again, here we have an example of storage tanks. This was 6 storage tanks, and based purely on nitrogen consumption, you can see the numbers, and I apologize, they are in euros as opposed to rupees. But if you add 2 more zeros on the end, you get an indication of the kind of numbers. These are huge savings that can be achieved just by implementing a better quality of breather valve. The safety is not compromised. The valves will open exactly when you need them to. The engineering and the research and development that goes into these valves is ensuring that when they should be closed, they are closed and not leaking, and therefore saving you lots and lots of money. Just some of the reasons why these valves leak in particular. We've seen competitors' valves where they try and glue the seats in. It's a really bad idea, particularly in a corrosive environment like biogas. And I'm going to skip that one. Just looking at the emissions control. Yep. Some of the technology that you need to incorporate, and again, this is mainly for the slide deck, is making sure you have that high quality sealing surface. Some examples of installations, one of those is here in India. And then also the critical nature of the maintenance requirements as well. And that's me. Thank you very much.
Thank you so much, sir, for this technical presentation on pressure vacuum relief valve. Ladies and gentlemen, with this, we conclude day 1 of the 5th edition of BBB International Expo and Summit 2026. We thank all our esteemed speakers, our delegates, and all the attendees for attending day 1's proceedings and making their presence felt. Whatever questions you have on your mind, you can send us those questions offline. We'll be happy to take them. And now we request everybody to kindly proceed towards the exhibition area, and you can network over tea and coffee. Please have some great conversations and be there for day 2 of the BBB Summit and Expo 2026. We are going to have some wonderful thematic sessions along with some fireside chats and technical presentations. So thank you so much. Have a nice day ahead. Thank you.